Oh, hello.
Yeah,
My screen is visible.
yeah, visible, sir.
Yeah. So, good afternoon, all. Okay, today, this course is going on from 1st December. Today, our topic is more on Indian Space Science Data Archive opportunities for students to analyze. I'm Himanshu Pandey, head of Indian Space Science Data Center. I will be briefing you about Indian Space Science Data Archives and the opportunities for the students how they can analyze. So, for any data, what we want to analyze, most of the thing is we should have sufficient tools, libraries, data sets, computer environment, and all those things. So the first question comes in mind, what is space science data and why analyze it? And what would be our skill building pathways? So anyhow, it is a very nicely curated course which you are going through, where the skill building exercise and all those things are going on. As per the topic, whatever assigned to me today, I'll be more talking around different type of data sets. Specifically, the major data sets, whatever available is satellite imagery, Earth observation, astronomical data, planetary and space science data, lunar science data, helio science data, and telemetry and orbital data sets, and telescope time series data sets, and etc. Various kind of data sets are available in today's world, which is acquired from the satellites. So, what the students needs, sorry, one is compute. So, most of the students, they are having either laptop or PC. And in fact, if you are in some organization or working in some college or students, there are some servers are also available. In fact, cloud servers are also available. Then, along with that, you need sufficient tools, softwares, and libraries. Apart from that, you need some basic knowledge and understanding. And you should have some objective or aim in your mind. The first three things, the four things are very important. After that, finally, you need the satellite data or space science data. To do all those things, most of the people getting laptop, PC servers is easy. You have with you most of the times. You can download tools and softwares from various open source resources as well. And college and universities are giving knowledge and understanding as well. And there are a lot of online courses which ISRO and our IRS they are doing. Jigyasa is also running, which is imparting the knowledge and understanding. And objective and aims are as per your wish list, which domain you want to work, whatever domain earlier I have shown in this slide. Now coming to the satellite data. So you see, satellite data, getting the satellite data only, we should know what should be the source. So for that, we start now because the space science data analysis, it is a very highly skilled and high opportunities. So if you start today, definitely there's a huge demand for this satellite analysis. Now students can start with open data sets and free. When we talk about open data set, our main target is open data set today. So I'll be more talking on all these fronts so that among all these verticals, this is the most challenging AutoCAD data. So I will be going through and taking you through entire process of this various kind of space and data which ISRO has listed. And second is open or free. They are free assets. Okay. To come to that, this is the most important thing is ISSDC is the ISRO Science Data Gateway to the scientists, students, institutes, professors, general public, researchers, principal investigators, and guest observers. It's a ISRO's repository of space science data. So what it is doing, there are many data centers available in the world. A data center is a centralized repository with a physical or virtual for the storage, management, dissemination of data and information organized around a particular body of knowledge or pertaining to a particular business. Similarly, ISSDC is also designed to host specific services and achieve defined goals. There are few about ISDC and space science. I will be touching upon all these aspects. The main objective of this data center is data ingestion from various ground stations, processing and archive, and dissemination. service to all the space science missions of ISRO with a vision to support all internet missions, Euro missions, known space flight programs, then other science missions and deep space missions of ISRO with state-of-art technology and also collaborate with other space science data centers of world to facilitate quick availability of data to the user community. Just to give a glimpse of ISSDC, it was actually established in the year 2008 at Indian Deep Space Network. Until now, we have completed missions like Chandrayaan-1, ISSB, ViewSat, Invertropics, Mars Orbiter Mission, INS-2 Chandrayaan-3, and INS-2P, the Bhutan Sat. An ongoing is AstroSat, Chandrayaan-2, RPL-1, ExpoSat, Chandrayaan-3 propulsion module, SpareX-A, SpareX-B, and upcoming Chandrayaan-5, 4, Mars landing mission, Venus, Disha, and many more. They are already lined up. The third function is data ingestion. Data should get ingested to data center, it should get processed, then archival, dissemination, then various web application hosting, mission-specific data pipelines, and application development, and IT services and automation. You know, there are these are the things required to provide the data. The most important thing which we are focusing today is data science and analysis. Now, to do the data science analysis, we should be aware of various standards. So you see, there are standards followed in mostly in planetary science. One of them is planetary data systems. I think yesterday also our colleague Ajay Mata touched upon it a bit, but since it is a science in the center, I'll be giving you a little bit more glimpse of these planetary data systems, files, archival formats, planetary data access protocol, structured directories. So you see, any missions when starting to become more interoperable for the long-term use, we must follow the standards. So when we start following the standards, so PDS is for keeping the binary data in your standard format. SPICE is keeping the HK data or satellite quality data into the SPICE format. And if you don't have any specific format like earlier missions, we have to work out our own archival formats, how we should start, and how to access the data and make it a proper structured way. These are the standards, how to organize the data. But finally, the data should be generated into a meaningful way. A meaningful way is this is called file format or archival formats. So like astronomical data, mostly they are in fixed flexible image transformation system. Or if you go to megatropics and other missions, it is kept in character data format 5. Then next area of imaging data is in IMG, hyperspectral data is spectrum, and other program counters data is DAB or DAB, or some information is TXT, some information, some payloads with some levels are kept with CSV, some imaging with geo information with GeoGIFs. Like there are various archival formats. So it should be compatible to that. Now coming to SPICE. What is a SPICE? SPICE is actually giving the information to us about spacecraft, planet, the instrument, orientation, events, and all these informations. Yeah. Once again, hello. I call you back. Hello. Yeah. So sorry for the call. So spacecraft, it will give information about a spacecraft. So I'll just give one glimpse to you. Like suppose you have taken a photograph of particular area. Now that area belongs to what region? How will you know? You will come to know by seeing by understanding or by gaining a knowledge on spacecraft's attitude. So spacecraft attitude means which direction spacecraft is seeing, what way it is moving, what is the platform status, where the instrument is mounted, how it is mounted. All this information will be seen as a part of SPICE. So this is the most important thing to understand and analyze the data. There is also hosted. A data center is hosted here, which is co-located with the there are deep space stations like the and there are many more there too are there. This is another view of Indian Deep Space Network where you are seeing that stations are placed here. This is the mission operations control center where actually the entire satellites are being telecommanded and controlled. Now, this is an inside view of our data center. This is another view of data center. The main features of this one is multi-vision automated data pipeline for different applications. So entire data, when it is received, how it should go through the entire process of uh, generation, processing, archival, and dissemination to view all. And before that, it will be disseminated to the evaluation center and some investigators. Then also keeping the data into petabyte scale, high performance storage, various network domains, automatic monitoring, with various kind of technology like SAN and MNS. This was planning generation of intelligence in campaign mode because science development for the re-generation of this one before supplying it to the community, all those things. And there are various other features which is as per the guidelines we have to follow. And interface are very specific uses for an institute for data exchange and technological science and technology. So there's four pillars of this one. Each and every level, there are various things happening that I'll be just quickly telling. It is a typical diagram here. You know, data once it is received from the ground station, it is coming to our data center. It is for ingestion. So there are telemetry data and there are payload data. Payload data is received in two modes. One is the real time and one is the offline. And then it is being processed after that level 0, level 1, level 2 processing will happen. And then for imaging, the image processing is specific. And then other ST data will go to the control center where it will be archived. And then it is stored into different tiers of storage. And with the diode, it will go to the outside layer. And then to the this one where the students and candidates can receive. These are typical diagram. So if you see the layer diagram, this is the thing where ground station network is connected and there is ingestion layer, then science data network, data action network, destination network. So here you will be connected to this particular layer. The data will be received at this layer where all these things will be happening. Each and every layer, very specific functions and activities are defined, which is being done. So if you see ingestion of the payload data from any of the ISRO ground station, from Indian ground station, from IDS and deep space ground station, can be a real-time data, offline data, visual operation messages from control center, and then payload from the external ground stations via different layers and data schedules, navigation messages, operation messages, and all those things we receive. Then coming to the external space stations. So Earth is revolving. Indian stations are mostly in the region, but Earth is revolving. We want to have a data set received or satellite continuously providing the data when it is around the Earth or around the Moon, Mars, or Venus, any planetary body. So we should have a ground station in other places also. Sometimes it is Indian stations or sometimes many are foreign stations which is collaborated. So in case of foreign station, national stations which is collaborated, we have to receive data, keeping our data secure and intact. So there are various ways in getting ground station national network, foreign ground station on dedicated link, foreign ground stations on internet via VPN, foreign ground station on the cloud or AWS, foreign ground stations using SLE or from the external layer. All these methods, the data center is designed in such a way that it is flexible to receive data from any of such combinations. And finally, with the quick look data processing from any of these stations, it will come to our quick server and it will display. Actually, quick look display thing is like it is like before, without doing any processing or advanced this one, we should be able to understand which mode we are operating. It's a like primitive preliminary investigation on the data sets where we can understand that my payload is getting operated perfectly, what mode we are operating, which direction we are seeing, we are really seeing the goal is coming, we are seeing our area of interest. All those things will come to my software in the real time data. After this one, the data once it is received here, it will be sent to our IGC and it will be given to 11 processing. We have also actually one regeneration processing. So specifically in science data, when data is getting processed, sometimes after some time, there would be some feedback comes from POC, PIs, and data needs again reprocessing. In that case, there is a mass regeneration processing. This is the ongoing active processing of daily payload or dump wise or orbit wise. This would be all really data can be processed together and can be given for the permanent archive. So, and the destination. After that, for a specific payload, a specific level 1 processing is carried out, which is actually you can say like arithmetical enzymetry, shortcuts, and geotagging. This on this processing level, I think yesterday my colleague actually might have preview. So I did not go in depth of this processing, but this is a typical chain which we are mentioning here. And then level 2 and high level product generation is specific time, and it will go back to POCs. Finally, all high level product generation things will come back to us and will be archived. Now, how archival? Before archival, we have to do various things. One is defining the filing conventions, defining storage areas, transfer paths, archival paths, pension period, backup policy, and the data. Everything is being monitored by several processes that are defined here. And before making the data available to you, it has to go through a various process, such as, payload data reception, payload data received, then it would be generated, level product, archive compliance check as per standard will be carried out. It would be given to the science peer review. Then after that, quality check and verified be performed. Then handed over the QC clear data sets to ICC. Actually, this entire process, they will go for mass regeneration and repetitively many round of verifications and reprocessing. Once all those things are done, then after lock-in period, PINSP, Science Programmers Clearance of Headquarter, data is released into users, and it will be available to all free of cost. Yeah. Now, for the data management and data analysis perspective, data management techniques are data sets are kept into a different kind of storages, which is already backed with a table library, different kind of table library, high-end processing, and processing is happening here in this plant. Once data is coming, any data which is getting generated is something which is actually going to the primary storage, and after some time, as per our policy, it would be taken a backup into the tapes, and one copy will be cleared to, and then this fault copy will be the data set, which is now got for fireproof data sets. Now it is the IGC is providing various compute, CPU architecture, storage, virtual machines, and memory computation kind of things. The most important thing that students should know about the data analysis. You see, why we should understand the data analysis? Because various national and international agencies have taken proactive interest in the standardization of data sharing formats. For example, like today, you have got a data and you have analyzed something and you generated some product. After some years, you have handed over to some other colleagues, or you want to open up. By the time, you want data from some other machines. Now, some other machine is data in some other format. Then it will be very difficult for you to understand the data, or you will spend a lot of time in first converting the data into your software or your utility format. So to avoid all those type of things, the standardization of the data sharing format is most important. So what will happen is whatever data you are getting, either from ISRO, NASA, JAXA, ISRO, or any of the space agencies, it should be in some standard format. So that it can save time and directly students can look into the data analysis part and start in the data seeing. So for that, what has happened? Various space agencies are participating. They are discussing from several detection protocols, develop a strong science data analysis. Okay. You can also go through and show you some of the screenshots also of that links. So that data can be made available in user-friendly and manner with the analysis tools and sufficient documentation. It will be flexible, interoperable, and interactive data archives, modeling centers, and virtual automation. This is the one of the place you can see International Planetary Data Alliance, IPDS. IPDS actually aim is to maintain the quality and performance of data from planetary research using instruments in space. So there are so many space agencies that are contributing in that. You can see ISRO is also listed in one of them. And once you go to the data archive, another things, the ultimate purpose of maintaining the data archive is discovery, access, use of planetary data by worldwide scientists, developing an international standard, common methods for collecting and describing planetary data across international community, and long-term goal of seizing the data across system agency boundaries. And if you go to access to data, if you go to this URL, you can note down already planetary data or space science data from where you can get. NASA science missions data is available here. If you click on that, you will receive ISRO science data. If you click on this, you will reach to our data center. Your planet respond, and then ESR, JAXA, and all these space science data sets, they belongs to solar system data, Mercury, Venus, Moon, Mars, Ceres, asteroids, Jovian system, Saturnian, Uranian, Neptunian, comets, Plutonian system, and Cuberites. All sort of planetary data sets are kept in very, very standard format, and all these missions are available in a single place. Okay. And all these data sets are available into a standard called PDS4. To understand more, if you click on this, see in this website also, current policy standards. If you click on this, you will come to the PDS4. PDF4 will give you full information about purchase, access protocols, registrations, PDF.master.org access. You understand about entire thing about PDFs, then data object identifier, data citation. Then there are some virtual observatories also where astronomical data uh, uh, keeping in PDFs standard also is being discussed. That also you will have understanding. Now coming to astronomical data, like ISRO is having various astronomical missions. Here also there is an international community called IAU. IAU is working on similar type of thing is to promote and safeguard science from this one and maintain to the international cooperation in generating the good standards. So IAU is having one FITS working group, which is actually working on the improvements and maintaining or endorsing the FITS data formats and helping the entire labor community to ensure that should be as per standard and evolving any new improvements into the standards. Similarly, once you come to the review data, there is an interesting review data analyze where you know that it is called ISTA. ISTA also is hosting various standards, group, best practices, and tools. So when you click on the services or tools, standards will be validation, tools when you click. These are the things that are available. Like if you go to one section, tools, all automatic tools are available. You can download those tools with your Word, Python, Autopilot. But the thing is, these tools will work when data is kept in instant format. So there are standard data formats. You have to generate science data. ISRO is also generating science data into these standard formats so that once you have a data, you have a tool, immediately you can open up the data and then start working on it. And metadata also is stored in standard format. You can also access from your program freely, calling this APIs. There are visualization tools also available, which we can use. These are all are free of cost from this link. You can go there. And other working groups also, if at all you are interested further, you can participate. You can also contribute. You can also convey your concerns and it will help in evolving further. Now coming to the main point, our ISRO's science data archive. Once you click on that ISSDC.org, in that we have ISDA page on ISDA. ISDA page will take care of all ISRO's science data products. So now what ISDA contains, it is containing lunar, Chandrayaan 1, Chandrayaan 2, Chandrayaan 3 data, astronomical, astrosat and exposat data is available, geophysics and TL1, interplanetary mass recognition data. One thing I want to convey today is astrosat has completed 1 decade in this year in September. Full 10 years of data available and all other data sets also. And you know, these are the ones you click on the IGV website, these are the grids. Further, if you know previous about previous also it is mentioned about local television and exposure data was released. So below, if you can scroll down, that exposure grid is also available here. Now coming to this PDS. PDS is actually a long-term preservation of data, which is having some level of structure and organization, where you call that is called ISRO Science Data Archive under the Chandrayaan 2 bundle. Then in Chandrayaan, there are three posts. One is CHO, is orbiter, there was a lander, rover, CHO, CHR, CHL, like that bundles are there. Under that, there are various mission phases. This is NOP means normal operation phase. So there are early, there are outbound phase, there are lunar bound phase, there are PLIs, okay, transfer trajectories and other things. And then after that, there are instrument collections. These are the instrument names based on the instrument collections. More things you want, that whatever I mentioned about PDS or data at ISSDC. Now coming to PDS, once you click on that link, you see on the home page of this one, already data search tools standards. About PDS, very nicely it is written and entire global community, they are referring this. And data users such as digital students, you being a student section, definitely information about these chat. You can also understand about PDS, what all things it is doing and whatever it is very simple, very easy tools, which it will be useful for data understanding. You can download the PDS video also. If I click on this, already PDS, you know, December 2025, already the PDS4 bundle, this particular thing is released was number 4. You can download PDS4, parser, libraries, validation tools, metadata, local HTML, everything is available there. And you want to understand the standards, the standard documents are also available. We are also following PDS4 and PDS3 we were doing for Mars and Chandrayaan-3, Chandrayaan-1. After that onward, everything is PDS4. See, recently Chandrayaan-1 data is also converted to PDS4. So this is one glimpse of how the archives are maintained, specifically in Chandrayaan-3. So you see, latest missions archives are maintained in PDS4, which is entire globe, same thing is being followed. It comprises of data, associated metadata. So ultimate thing is when you want the data, you have got the data, but what are the associated metadata? What are the mission information, instrument information, what are the calibration data, detailed document, necessary tools. So actually, the previous declares in such a way that everything what you need is a bundled together and it is provided as a part of that. And different levels of data are also provided, like raw, calibrated, terabyte, and now even the anthems are also available in our website. I will be showing a screenshot of that. Then provided with separate XML schema, various data formats are this one, and custom dictionary is also there, which is mission specific, it is available. So now to help you to download data, what we have done is, you see, when you see data is orbit wise dumped by John 19 data, 20 data, 21 data, 24 data. The data will be keep on going based on so day wise products. So we are keeping this way hierarchy like raw data and DD MM. So in is device direct. You can go there and download the data based on that, or you can search the data. What we did is day-wise, we have made a zip and you can download entire this structure from zip. But a few things which is starting is information about uh, mission, information about calibration file, context, all those things are fixed. So this what we have done, we have zipped together. This should not be bundled, otherwise it will be and again and again. We have put as a one-time downloadable data sets separately into our archive. Okay. So this is the structure which I told payload here and they are it is maintained. And when we download the data structure based on scientific communities, you can say usability, archival formats are science and remote sensing community driven. They are not like we can generate in any format. All sort of formats are compatible. Now there are various modes of data access. One is SFTP based, another is FAT based. SFTP based is for our payload specific PI uses. So I'll be skipping that particular section. Main thing for you is web based. Now web based access, what we have to do is open the URL isdc.org or done.isdc.org. Then you have to log in. If you have already registered, you can log in. But if you are a new user, you can register. Or if you are logged in and you forgot, you can do a reset or forget password. All the options are available. After that, you can select the payload and browse and download it. Filter the search results based on various parameters. View the metadata file size, select the data and download. You can also integrate with Download Manager. Download user guides, tools, calibrations, files, entire data, structured in zip. And there are a lot of references available, acknowledgement statement, disclaimers, everything is available. Okay, everything. Once I go to the next this page, this is our home page of our ISDC web. You click on this, you will be finding all those links here. I will be taking you first one of the other demo. Once you go here, channel 90, suppose I click on channel 90, or from here also I can select on channel 90. Inside channel 90, once I click on this, there is a data grid. Click on data, click on OK. Once I click on OK, I will navigate to my channel 90 the ISTA page. Now, once I click on this login, I will be able to access. In addition to this, one thing I want to think out here is there is a map browsed map based search also is available. You can search based on map and download the book. What it can give you is browse the science data, search the payload, specific parameters, location, observation, adding multiple filters, download data in compressed format, pause, resume, and group small files and download together, PDFs for compliant archives, such as between tuning and provision and very detailed this one and allow download one data. You see, this is the option login or forget password or new user. All these options are available. If they are new, there are set of fields you can fill and submit and you will upload. You will get an email and on that registered email, if you click on this, your account will get verified. Or if you're already this one, you can log out from here. Now coming to once you're logged in successfully, this is the first section called browse and download. You can click on this, you will see all the sort of assets and the screenshot is available here. click on any of the payload. Suppose if I click on this class, I will be landing into the class, is the thing. And first section itself, if you see user manual is available as link, that how once you download the data, how to use this data is another most important. By step user manual, full guide is available. Like that for other instances also. So you can filter the data. You see, now filtering of the data, it depends on various different parameters and payloads. So for suppose for class, these are the parameters available. For IRS payload, these are the parameters available. For TMC, different kind of parameters are available. You can add these parameters here, plus, minus, or whatever reduce, increase based on that. You can add a combination of parameters to tune your search results. You can mention here. Once you click on this, even the column also you can increase or decrease. That is also changing based on different parameters. You see, for IRS, we have a more number of columns. If you move this right side and add all columns will come here. You can understand, you can go through this before downloading the actual data. Another important is file size is also given. You can see based on the internet bandwidth available, you are using mobile data or you are using your high broadband link or some other institutes internet based on the size, based on the metadata, based on the file, data of this one, you can see which is more relevant. Based on that, you can click and start downloading. So when you see the data, there are both the data sets, metadata is available in XML format or in PDF level. So if you go to PDF level, you see start time, this time when is full, you can drag it down and see more details. Even XML also, even though you see left and right, full entire corner coordinates. You see left the top left right left long, then upper right left long, lower left left long, and lower right left long. All four coordinates, everything you mentioned. So that way also entire information which mode is written, which instrument, so that you can go through this and then see whether it is falling in the area of interest. You can search also based on these parameters and then start downloading data. While showing the product, you can show multiple number of products in a single page. Click on 100, you will see all 100 together. You to see more data products in a single console. Sometimes I want to download multiple products. I click on this full entire will get selected. Next option is given is you can select from 185 up to 10 MB for a small size file it is provided. Select. So automatically our system will start from 180, keep on calculating and up to 639 just MB. And it will select automatically. Then click on download. That's all. For you, no need to do. It will take some time for shipping all the things and provide the link to you and we start downloading. So another is most important thing is user systems. You see, what I told is entire PDS archive. So PDS viewer will work is given here. Viewer will work if you have a PDS structure maintained. So automatically you can use here you see PDS viewer. You can just go file, browse the file, double click and open this one, click on image, table or label. All three information will get here automatically. But for that, what you do, you should have a structure maintained. So we have already provided the structure here. You one-time download, when download the structure, an entire structure inside data directory, you can keep on download, keep on copying the data. And so that's all. It will maintain the structure. So in the same way, payload is specific structure is also maintained. Once you download and open up, you see all those things will get already populated. Only what you have to populate is data, browse, and geometry. So these three things are coming under data. These are one-time things. So other downloads, I am just showing here whatever is relevant information with respect to the structure, documents, calibration data, utilities, software, and everything is available here. And you see, we are also hosting the updated versions of software. Like suppose SAR payload you want to open and analyze. There are already meta software which is built by our SAC team is already hosted there. And the new version is also released recently. So like that, all these sections you can go through each and every instrument specific details, calibration, documents, everything is available. Once we go to the even there are few data sets of CHT class where higher level L1 data, which was specific to particular thing and used in sense this one that is also made available so that you can refer that and download that latest calibration files. Now coming to user manuals, you see data products, archive documents, all payloads user manuals are posted for you. Just quickly go through and just go to step by step. You'll be able to understand the data, interpret the data, everything you will be able to do that. Now you can see the history and the statistics also. Once you click on what you have downloaded, what is your history is any downloads, you can see from there. And FAQs, most important. Every time some students or some our users, they are asking some questions. So what we are doing is every time we are getting populated this information with respect to common questions, with respect to instrument specific questions, expanded view, whatever is most frequent questions people are asking, we have already populated here in our website so that it will definitely, if you go through this, will help in resolving most of their questions there itself so that you will be able to use the data in more effective manner. Once you use the data, then an acknowledgement statement, if you are going to use this to publish something, this is a statement you may have to use. In any data, if there are some concerns or something, if there are disclaimers, you can go through, that is also mentioned. And if you also want to interact with the particular PI or a payload operation center, the names of the contact details of each and every person is given. When you are analyzing data, you can also talk to them one to one and take that help. That level provision is available. Like some of the data sets in known affairs, even there's a big critter named on father of a space science program, Dr. Vikram Sarabhai. His name this crater is formed. It is around 1.7 kilometer depth and then it is around 8 kilometers. That is a 3D or 3D them and this is the author image of that crater. And today OHRC is having the highest resolution in the world, which Bachmaran 2 is having. Even a lot of space agencies on this one, they are asking OHRC to do an imaging of the landing surface where they are targeting to land in their future lander or rover. They are asking ISRO to provide this data and we are continuously providing it. So this kind of fine resolution, small features are also visible now. And this is the highest, you can say, dual frequencies are in the 2L and S band, both it is working. It is giving the highest resolution subsurface information in different polarization level. One of the fantastic instruments which ISRO has. Now coming to the astronomical data. Quickly, I will just tell you if you want to download astronomical data. It is one of the you can say fantastic observatory which ISRO has done. Earlier missions they used to monitor the outside celestial sources things in some of the frequency band. Astrofed contains entire from soft X-ray, hard X-ray, NUV, you can say UV, IR, all bands, so that we can monitor the same thing in a very, very high resolution. This one. So you see, here are a few of the images of AstroSat, which has given a very good information. Now, what we wanted to do is show you that data access. You click on the data access from the IGC portal, you land on this particular website. Once you click on this and register, if you are not available, means registered now. Otherwise, with the existing account, you can log in. Once you log in, you get all this uh, search and other download options. Once you click on the search, and if the asset handbook is available, you can go through it. Once you click on search, you can give the object name and click on result and send. It will automatically the array deck will get resolved. For example, I'm getting cab habla result. Automatically the array deck will get resolved. I can tick all payloads should come and click on this. Once I click this table, will get populated, which is also giving some 25 observations of 1623 rows. So once I see this section and click on L1, the file will get downloaded. It will also give me the information about instruments and context I can go through. So when I click on this product details, the entire label will come here. I can go through this label in this area of interest. Even the concerned source is in which place in sky map also can be plotted immediately by clicking on this. So based on that, in fact, if you are not knowing that instrument name or something, I can click on another menu. Oh, and this also with mouse or other things by giving these parameters, I can navigate and see which source or which area I want to search. And then taking this object name or index, I can again do that and search really on our area of interest. Like suppose I navigated to Vega, now Vega star and see that current Vega R index is 279.30 and I can go and they are going to. So like that also there are other ways which we can help. Now coming to softwares, there are various softwares which are already available. You can download from there and instrument specific information. You can also approach us. The other thing in the Chandrayaan-3 which I have mentioned about map browse, home page of map browse or along with TMC also map browse is mentioned and below also one page is there on map browse. Once we click on this, if you are already registered, same credentials will work. It is for imaging payload. Click on next. This is the help which will tell you how to use this application. Once you click on this sheet articles about these two payloads, already these two products are already listed in this plotted here. Now, when I go there and want to download something or search something, what I can do is I have selected this or this field. If I just click on this, select this, you see automatically get, or if I select this will get highlighted and click on download and will download. If I zoom out and give a different polar region, there are multiple, you can say projections are there. So it will show me in the data sets also, and this keep on increasing. Now coming to Chandrayaan, Chandrayaan also there are some 11 instruments, and these are some of the images which are hosted. And you know, Chandrayaan is always known. We are seeing only one face of the moon. Other face of the moon, if you want to see, only the satellite uh, is possible. Through satellite only it is possible. These are the MIT images which were before the touchdown in the southern pole of satellite crater. Frames were provided to us. These are the few frames which we have received from Chandrayaan 1 Moon Impact Probe. So all those things are available on our website. Once you click on this, okay, I will not go through full search with the MCIC, AO payloads, DEM search of full 35-meter timer, Atlas catalog is available, Spice is available, Value is data is available. These are small data, the fully available single zip file, might be their data is available single file, down, everything is available single zip file. Their mosaics are also available, everything is available here. But it is in PDS1 and recently PDS3. Recently, PDS4 archives also we have made available. It is under Pradhan Chandrayaan area only. Now coming to Mars. Mars also, you know, it is a critical development line on to full all verifications and everything, and it was released. And then it was released by then Chairman ISRO. And before going, a lot of data sets Mars has given to us, Mars Orbiter Mission. This is one of the image of this Earth, and this is also Earth. And this image is of one of the largest, you can say, volcanic activities or which is formed on Mars surface in available here. There are some 3D resolution images of Mars. So all sort of analysis and data sets you can download and you can also evaluate. So how to do? You note down this particular website, mrbrowse.icg.in, or you just simply remember the IGC website and then uh, open the portal. This type of portals will be coming. You can also select through mouse, click, all the sets will come under this, or in a tabular format, click on this one, say tabular table based searching, map based searching, both options are available here. Okay. And so MMC data was released on 23rd September, August 2024 last year. Since then, it is being used. All the 5 payloads instrument data from different instruments, a lot of volume in the data sets up to 24 MB is released. And you know, there are few payloads like lander imager, rover camera was navigation camera, rover camera, and there are uh, lander payloads from pitch Astralisa and rover payloads VPX ellipse. All are available there. Once you click on this and log in, there are this option means entire data you can download and visit. This means you can still go and browse the data as per your area of interest. So once you click on this, suppose I have gone in the uh, lander imager data and clicked on one of the preview. Immediately let you see images coming. Now if I go on to a rover imager, rover I can go and click. Clear cut PC entire rover track. And this many modern images, there's these data sets are available. You can see thumbnails, you can download the image, you can see the metadata. Everything is available. You see, fantastic. This one you can also analyze by seeing this. You can understand the soil characteristics also. There are various scope of when one wheel is going after that second wheel is coming. How the second wheel is destroying the imprint of the first wheel, and then what other disturbances are happening. How much is the fire soil is soft or fluffy? All this information will come from that. Then coming to navigation. Navigation camera was used for our doing the entire development maintenance one. So you see, we are looking at the structure is different. So that shows that after that there is a crater, and these are other surface. This coming line. You see, here also this line is the crater. The navigation thing was happening, and then it has gone up to this point. After this point, there was a crater here, so rover has to come back. When the rover has come back, then the entire retraced image of the rover is also captured using the navigation camera. You see, it has gone and came back. Now we are spot. And this is a fantastic image that you see. The crater was this side, crater was this side also slope. So rover has to move on this crater ring across. That level challenges and the things rover has gone through during the entire process of the planning. And all sort of data sets are available. So one of the historical image which rover has taken of land sitting on the moon surface. This is also available for you. All the data sets are available. You can download the PIPS's image are also mentioned. You can access. Now coming to Aditya, the data sets were released this year by our chairman ISRO and to the entire community. This is also accessible from here. You can access data, click on this. All the payload data is available. If you click on suppose suit, the suit is having multiple bands. How the sun is being observed in different frequency bands gives a very vital information to us. So you see in one band, it is very simple, only some features are there. Other band, it will have a different features. So all those things are available, including same style, like there are common data sets, user manuals, and all those things are available. You can refer. PIPC is also after downloading data. If you have any concern, you can discuss with them. With respect to data, if you have any concern, you can approach us. And exposure data just recently, 13th of October, it is released by the chairman. So, and if you go there in the website, exposure is also listed now on the website. And in that also it is added exposure in the grid. And once you go and log in, both the data sets, colleagues and experts, there are two instruments in exposure, both are available. And suppose I click on experts, this will come out here again, the similar style, the multi-vision application where you can download the data. And there is a very important aspect of the science community regulations like exposure, astrophotometry, where we are also making there are tools called expert viewer and there are definitions of the proposal processing system. Actually, there are a lot of users and scientific community, they are submitting the proposal to PSRS viewer. It is going to our scheduling another release, then operation plan, and then accordingly it is development, and the time between downloading, process, channel to generator, then business side, and posted. The ultimate idea is the scientific community will dictate which payload will operate and observe with which particular source for how long duration. Like that, they are submitting the proposal in advance. It is being reviewed, and then accordingly, only the mission is getting operated. This is the one of the glimpse of how the processing systems. Opportunities, submission, review, planning, observation, download, pursuing, document. The entire thing is provided with this application. You can also go through if you are interested. And you can, before submitting the proposal, really expert side will see that observer in a particular source or not. For that, that tool also is made for viewer. And from there, you can put a tool and then it will generate the entire visibility suggestions. So based on that, you can pick and submit the proposal. Is a typical proposal processing timeline or maybe a possible this 1 hour data pipeline where how it is happening. Normal users, they are submitting the proposals and PIQC is also submitting their payload variation, transit time, and things. And it is going there as a part of this. And committee mission managers are approving and reviewing all those things, consolidation, conflicts, all those things are reviewing based on separate constraints. Then it is going to the master database with some observation ID. Accordingly, it is going to the plan to our system to a control center. From there, it is being checked and then again sent here for proper final plans. Now these final plans are getting finally uploaded among everything. Then data is coming from the station, processed, and then finally the same observations are here. Received here, processed, and done twice, locking period 15 to 8 and after that, what will happen? It will be available to housing the simulation. So this is the high level products. Whatever was submitted, this one submitted, and this one. Finally, after this one, there is a pay preparation, generation, everything will happen in this point to PS community. It is actually a central thing between all these users. This is a typical pipeline, then 1, 2, 3. So this is in a simple way. Level is where data comes. The submission ID products are provided here. Then ignition to program and notification is provided. Now, Aditya L1 control vision system. This is also planned to be released for soon. You know that as of now, the Chandrayaan-2 landing point is declared as a Tiranga point, which is a point on the moon where Chandrayaan-2 left its imprint. And Chandrayaan-3 touchdown point was ordered Shakti, Department of Government of India. And National Space Day at the Chandrayaan-2. We can celebrate every year on 23rd August of this one, because India has become first country to land on the moon South Polar region and fourth country to achieve soft landing. Thank you. Yeah. If any questions, I can pick up. Otherwise, yeah, presentation will be. Thank you.
So we are looking for some questions.
मिल जाएगा साढ़े पचास तब तक करे 20 दिन 25 दिन ना
Hello. Hello.
We're looking for some questions. If there is there, I'll paste it. Just wait for few minutes.
There are huge opportunities with respect to data science and machine learning in space science domain. If you go on see one other thing I will tell you, 1 second. See, you can use like suppose if you are trying to work on image processing domain, there are like crater detection, crater analysis on Moon, Mars, surface mapping, cloud segmentation, change detection, even time series research also like solar flare prediction, sunspot cycle modeling, exoplanet transit detection, machine learning if you want to use like galaxy classification, asteroid detection, anomaly detection in spacecraft, even telemetry. Even there is a spice data which I told you is available. You can use TLE data using orbit decay prediction, collision analysis. With respect to space weather is a huge opportunity. Geomagnetic storm, this on like 12th and 13th, there's a very huge storm came. It came in news also. You can predict those things in advance by using the space science data, atmospheric disturbance and modeling, aurora protection, and even even like our Google Earth type of thing, Google Earth type of thing, Indian company, large telescope surveys or distributed processing, then data detection using the CNN or exoplanet transit detection or urban expansion. So there are a lot of opportunities to do that. One level is data cleaning, scientific coding, then modern building. All sort of things are required as a part of you can say, a part of activity you can do. You see, computer vision applications mostly if you want to see is imaging data. So in Chennai, there are TMC, IRS, there is a DFSR, there is a OHR signatures. Even in Aditya also, there is a well, if you see, mom, there is a master camera, all sort of imaging applications that data sets you can use it for that purpose. Okay, NASA's ISC asteroid search campaign. Is there any citizen scientists from ISRO for students? These are the questions from. Okay. You see, I think for ISRO perspective, citizen scientific is scope, and there are various so many things which ISRO has initiated. And our director from the capacity building program is going to talk about this topic. I think on 5th of December, specifically one potential talk is arranged. So he will be telling you there are a lot of opportunities. You will come to know on that day.
Okay, thank you, sir, for giving a nice lecture. Thank you very much.
Okay, thank you all. Yeah, good luck.
Thank
Bye.
you.